RefComm 2020 Virtual Symposium. Welcome to our booth. I'd like to do a little company overview of technologies, discuss some of our manufacturing capabilities, our product lines, and then some of the applications our valves are being currently used, very reliable in refining processes. We were founded in 1987 by current owner and president, Mr. Kevin Hunt. We're one of the leading global manufacturers of severe service metal-seated ball valves and parallel slide gates for zero leakage, safety of isolation design valves. We're currently completely stay current on industry codes and standards. As mentioned, these valves are totally manufactured 100% USA in Houston, Texas. We also provide support for our products globally through worldwide service centers. We also do a lot of coker valve repair within a lot of the US refineries and some of the Canadian refineries. Some of the manufacturing capabilities we have, as you see, we have totally automated machining centers. Slide there showing one of our large diameter assembly areas, automated testing machines, computer operated, and just an overview of our company in Houston. We also have state-of-the-art automated ball grinding machines. What's unique with this operation is we're able to get our balls all the way up to 42-inch, machined and grinded with an excellent surface finish before they go to final lapping, and also to a true sphere, true roundness, which is critical in the valve providing tight shutoff, safety of isolation. We also, within our facility, have a complete welding department. Both automated and manual welding capabilities, showing some of the pictures there of doing some overlays within some valve bodies. Showing you the department located within the facility. We also have three totally robotic, computer operated hard coating machines. What's unique about this is we control our own quality of the coating, which is critical in severe processes, high thermal application, particulating streams, so that the coatings are lasting the true life of the valve, so that you get the reliability that you're expecting on the applications to be used. We also have within our facility a R&D group where we have a lot of times designed specialty valves for unique applications for customers. We also do continuous improvement on existing products, testing, like in this view here, you can see we're doing some thermal blanket work or testing on a particular valve design. Now we'll talk about our products. As mentioned, we manufacture a complete line of metal-seated ball valves, both our fixed integral seat valve and trunnion design ball valve. And then we also manufacture a parallel slide gate for the power industry, for high temperature steam applications and hydrocarbons. This is our fixed seat designed ball valve, which was original valve that the company was started on. What's unique about this design versus other ball valves, if you can see in this picture, the left-hand side of the body, the seat is machined into that body piece. So we basically eliminate a component that the majority of other ball valves are manufactured to. It's also loaded by a high pressure or high force contact pressure Belleville spring to help keep the ball seat faces clean and protected against any migration of particulate. This is showing the basically an exploded view of the design of the ball and the seat. We only have one sealing point to achieve in this design, and that's why we test this valve above industry standards such as API 598, where we test internally to zero leakage, bubbles, both high and low pressure testing. Other ball valves will utilize what we call an unseated seat ring. With this design, you have two sealing points to manage, the ball to the seat and the backside sealing area, which is usually the sealing component is a graphite material. This can be affected by thermal cycling, where you have different masses of materials, the body mass, the seat is less mass, the ball mass, and also different materials. So up on thermal shock, they want to move relative to one another. And you can get migration of catalyst or coke fines or like heavy resid back there that can solidify and cause issues with operation and leak by. The graphite seal that you have to seal that backside also can be affected over a function of time and temperature and start losing some of its mechanical properties for load retention. We eliminate that piece of component within our valve due to the integral seat design. So it's a truly metal seated ball valve for tight safety of isolation in your processes. This is our Next-Tech valve. This is a trunnion design. Some of the applications this valve is a very good fit in is high cycle applications, large diameter automation requirements. Due to the trunnion design, your torques remain pretty consistent and low throughout your pressure classes and pressure requirements. It's very good for catalyst handling, like continuous catalyst reforming processes. This is our parallel slide gate, as mentioned earlier in the discussion. We provide these valves into a lot of your power plants for high pressure steam isolation, main steam isolation for turbine protection, but also we have provided these in refineries for steam isolation, high pressure steam applications, also high temperature hydrocarbon applications where some of your typical gate valves, the disc, stem, can get overheated and cause issues with the wedge jamming into the seats. This valve cycles very freely within and out of the seats regardless of temperature, and this provides zero leakage to the design of the disc and Belleville spring within the valve. Next, we'll go talking about the areas where we have provided our valves in refining. Typically, our home in refining processes is in the severe areas, high temperature, high pressures, heavy particulate laden streams. So the common areas where we work with our customers are delayed coking, resid hydrocrackers, your hydrocrackers, your hydrotreaters, CCR units, cat crackers, gasification, and vis braking. Vis braking is more outside the U.S., but it's similar to a resid upgrade process. Delayed coking, we have provided valves of pretty much the whole gambit within the process unit. Furnace isolation, switch valves, inlet feeds, your utility valves, blowdowns, overhead vapors. Also, high pressure jet pump cutwater isolation. Some customers like to isolate 2 drum modules so they can work on a module while keeping the other coke drums in service. Also, we have provided valves around your bottom of your fractionator, your pump arounds, and pump isolation. Key highlights of our product in delayed coking is our very effective purge design. Actually, in coker units, the most common failure mode is a valve coking up. So the purge design is one of the most critical assets of the valve. We use a live flow steam system throughout the valve. So the purge is continuously removing any resid deposits, coke fines out of the valve cavities back into the waterway. In this way, when the valve closes and cools, you have no resid trapped in those cavities to go into solidification and eventually cause operational issues. When the valve is closed, we're no longer using steam, thus keeping your water in your coking system at a manageable effort. Also, the valves are very easy to automate. Being a ball valve, you don't have any moving parts, just a coupler connection between the stem and the gearbox. So there's no moving elements in there, no high opportunity for failure mode. We can provide backup indication, as you see that external limit switch, to really give you true indication what position your ball is in the process, opposed to Hall sense effect limit switches within your actuator, which actually are not reading truly what position your ball is in. Then the other applications are resid hydrocracking. This is a form of thermal cracking, like delayed coking. Areas we have provided valves is in the reactor areas, catalyst addition and withdrawal. Actually, some of these applications are double ball valves. Separator isolation, your catalyst valves within your regeneration section, and again in your lower pressure fractionator bottom isolations. This again is very high temperature, like a coker unit. You have some cycling involved, and of course you have particulate, which in this case would be your catalyst. Just showing a diagram as you come into our booth and want to review our little virtual presentation showing some of the areas where we have provided valves in this schematic. Here's our double ball valves. We've had some of these installed at an LC refining unit in the U.S. since 1999, and the valves have provided excellent mean time between failure or maintenance before the valves are pulled to perform a repair cycle per your shutdown requirements. Hydrocracker pump isolation valves, and also depressurization valves. Next is your basic hydrocracker, hydrotreaters. We have seen a new surge of applications in these areas as some of your furnace and your exchanger isolation, where your typical conventional valves, either globe or gate, are getting a lot of heavy salt or chloride built up due to the content of the crude, and thus has some challenges trying to isolate some of the exchangers for maintenance. So we've replaced some of these valves with our metal seated ball valves. Due to the high load of the Belleville spring, we're able to keep the ball and seat area clean from a good scraping action from the contact stress between the seats. So we have replaced some of these type valves in these applications, also on some sour water pump isolation, cooling the fin fan, due to the same issue with some other type conventional valves of buildup on the gates and seats. A very common application that we work with some of the licensor is, as you see here, number 17. We call those depressurization valves. We have a pretty good installed amount throughout the world in these type applications. This is a unique design of some of the product lines we have. We have a refinery in the U.S. where in some of their hydrogen services in their hydrocracker ISOMAX process, they wanted a valve to be able to leave in line. This shows a flange valve, but in those particular applications, they were welded in due to concern of the hydrogen service. Instead of wanting to cut the valves out, which would be a very expensive endeavor, and do NDE on the piping when you weld them back in, we provided a top entry design valve. So when maintenance time or shutdown periods come and the valve needs to have any maintenance done, you just remove the top bonnet area and you can replace seats or balls in that type of valve without cutting it out of the line. Have any interest in this? This is unique design. We do have good runtime in this and references. Please come by our booth and we can discuss it. Continuous catalyst reforming units. These are there again. You have a lot of catalyst handling. You have some high temperatures. Where we have provided valves will be in your unloading systems coming out of your reactors, and also handling the catalyst going back into your regeneration system, burning the coke off the catalyst and the heavy metals. So we have provided both automated and manual valves in these, both combination of our fixed seat, integral seat, and our trunnion valves. They're mainly were being used for the automation aspect. Another area where we have really been very active in providing valves is the cat cracker unit or the FCC unit. Areas where we have been active providing valves is being in the slurry loop decant system and the bottoms of your fractionator where you have catalyst carryover, some coke fines, a little bit of temperature, say 650 Fahrenheit, somewhere in that area, where some of your typical valves to isolate the strainers on your pumps, protecting the pumps from the catalyst, aren't reliable for those cycle clean out on those strainers. So they've gone to our metal seated ball valve for safety of isolation due to the capabilities of zero leakage. So we've replaced strainer isolation, pump isolation, and also the same area in that decant loop, exchanger isolation. We've had very good reliability, good mean time between repair or failure on those applications. Other areas would be on your catalyst withdrawal valves, very high temperature, low pressure, but the valves can see a lot of severe erosion effects from the withdrawal of the catalyst lines. Also in the third and stage separators, where you're getting carryover from your flue gas coming to the regenerator, isolation on your separators and your lock hoppers, very hot service, very erosive. We've utilized valves in this area as well. We actually have a special design valve where you do for the withdrawal valves, do the heavy catalyst in the flow stream. We do a little bit different design than our standard valve. We design the seat areas where you have a lot of space, so you don't have the tendency of the catalyst to pack up. And this design has proved itself in service out of a kind of a migration of evolution in getting a longer runtime of the valves. So this is something we can discuss with you if you have interest. Disc braking is a process very similar to the resid upgrading, mainly outside the U.S. We have provided valves in Russia, in Europe, in your high temperature areas where you have some coke fines. So we have valves in this service as well. Gasification is an area that we have provided a lot of valves there. Again, you got high temperature, you have some coke carryover, charcoal, whatever you're burning in that system. And some of these areas on your filters, you have very high cycle valves, where we have upgraded our design on our Next Tech to take that extreme cycling on filtration and cleaning of those going through the filtration area of that process. That's the end of the presentation of our virtual symposium here and our virtual booth. We thank you. We encourage you to come by and visit with us, ask any questions on some of these topics we just discussed. Delayed coking valves, our resid upgrading, cat cracker, some of those areas where we have very good references, very good installed base to discuss reliability aspects of our valves in that process. Looking forward to the show. Thank you.